today we'll be looking at this question from JEE Advanced, and it is from the chapter of Gravitation. So in this question, we have Earth basically, and we have acceleration due to gravity given as g, small g, the surface of the Earth, and we have a well inside the surface at a depth, and we have a rope which is dropped into Earth like this. So this rope has mass m and length r by 5, and the radius of Earth be r. So we have to find the external force which is applied to keep the string subtended in the well. So first let me just draw a situation in which is a bit zoomed and which is more visible for everyone. So this is the well, and here we have the rope which is of r by 5 length and m mass. So we know that Earth applies a force to it, and we know that since this rope is not a point mass, there will be different forces at different point. So how we'll be doing this question is we'll use the approach of integration, and we'll go x distance from here and take the element of dx width. In this case we can show it as this. This is an element of dx width. We can write the mass of this element as we know that for r by 5 length there is m mass, so for dx length there will be 5m on r into dx. So we have the mass 5m upon r into dx. Okay. So now the Earth applies a force dng dash onto the rope on that x element, and that dmg force we can write as mass of the object into g dash, and we know that the g varies as this inside a depth x. So here we have this force. We can even write this force as df, and if we further simplify this, we get this, and now we'll just do integration to get the required result. So having f 5m by g here we have integration of x will be from r to r by 5 minus of r of course 5mg x square by 2 upon r square, and of course we'll have the limit So now when we put in the limits, we have this equation which equals this 9 mg by 10, and this is the required answer. So here's the solution to this question, and that's all.